Hey, good afternoon. We are starting with lesson 8.1 today. This one is more of a review from geometry and algebra 2, specifically based off of trig ratios, which is the sine, cosine, tangent, cosecant, secant, and cotangent. However, we are focusing on right triangles only. So, as long as we have right triangles, there are a couple of things we can apply on right triangles. Number one is our handy dandy Pythagorean theorem, and we all have done enough of Pythagorean theorem that we all remember that a squared plus b squared equals c squared. The only thing you want to be careful about is that in this right triangle, c is fixed. C is the hypotenuse, which is the longest side. A and B are the legs, and it does not matter which one you call A and which one you call B. So you can label them like that, or you can label them B or A. So that part does not matter. Now these are the lengths of the sides of a right triangle. Remember, this is the length. We're not talking about the angles. So Pythagorean theorem helps us find one of the missing sides of a right triangle given two of them. So if we have two sides missing, let's say I'm not aware what A and B are, then just by knowing C, I cannot find A or B. Similarly, if I am not sure about C or A, and only B is given, then I cannot use it. So we have to have two of the three unknowns to be able to find the third unknown. The other thing that we can apply on right triangles is trigonometry, which is the sine, cosine, and tangent, which is this slide right here. Sine is sine of the angle. So let's say this is the angle, is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Hope that's bringing back some memories. Or in other words, keep in mind that theta, which theta we're referring to, is important, because if we change theta, or if we alter theta, then the opposite and the adjacent are going to switch, and I'll show you that in just a second here. For now, again, keep in mind sine theta is equal to the ratio of opposite over hypotenuse. Cosine is the ratio, and that's the ratio right there, of adjacent over hypotenuse. Tangent is the ratio of opposite over adjacent. So in this triangle that's marked right here, let's call this triangle ABC. C is the angle theta, okay, which is the reference angle. So in reference to angle theta, let me actually redraw it here. This is 90, right? So let's say this is my reference point, and again, let me call this ABC. Now C is the reference point. Pretend you're kind of go and stand right there. Now in reference, and this is your perspective, okay? This is from where you're looking at that triangle. The longest side is called the hypotenuse, right? So this side is hypotenuse. That should be clear enough. Now, which side is directly opposite to me? There are only two sides left, AB or BC. Clearly, this side is directly opposite to me, and this side is right adjacent to me. And when I say me, and that's me right there. And why did I go stand there? Because theta was right there. C is the reference angle. So based off of this, sine of theta will equal AB over AC, right? Opposite over hypotenuse. Cosine is adjacent, so CB over same hypotenuse. Tangent would be of theta. Don't forget, it's the tangent of theta, whatever that theta is, the 60-degree angle, 87-degree angle, 15-degree angle, depends on the situation. Tangent is opposite over hypotenuse, so AB over BC. However, if I alter some of the labelings of this triangle, it doesn't look very good. There we go. It's a right triangle. It has to be right triangle. Keep that in mind. These trig ratios only apply to right triangles. Let's still call it triangle ABC. And let's say this theta is what we are either concerned about, or this theta is what is given to us. When that happens, my reference point changes, which means now I'm looking at that triangle from up there. This is my point of reference. Now, hypotenuse should not change because that's the longest side of the triangle, no matter how you're looking at it. However, when I go stand up there, opposite is CB. That's the opposite side. Adjacent is the one right next to me. And there are two sides that are right next to me, this one and this one. Well, one of them is clearly hypotenuse, so the other one's adjacent. Now, when that happens, all three trig ratios, they change. because now sine of theta is CB over AC. And if you notice, that was the value of cosine if theta changes. So everything changes basically. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent AB. Okay, so this is the ratio part of it. Now we haven't really gone into how do I find that angle, or do I have to work backwards and get sine inverse of CB over AC to actually get the angle. We will get there. We're getting there soon. But for the ratio part, these are the ratios. I've written down the ratios. Something over something. Okay. So based off of what we just went over, let's try this example. Very simple. It says write the trig ratio for sine. So it's only asking for sine. That's number one. And number two, sine of j, which automatically tells me my reference point. They're referring to angle j. I can call that theta if that makes you feel better. So sine of j is the same as sine of theta because it's referring to the same angle. And I remember that sine is opposite over adjacent, hypotenuse. By the way, I forgot to remind you of this whole deal, SOHCAHTOA. That's where that came from. Hopefully this should ring a bell. S stands for sine, C is for cosine, T is for tangent. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, just something to memorize all this. So I'm like, all right, sine of theta is opposite. Now let me declare which one's opposite. This one's clearly the hypotenuse. Between the 11 and the 60, this one's the opposite, and this one's adjacent. So I hope that part is clear. So opposite is 60, hypotenuse is 61. They asked me to write trig ratio, and I have written down the trig ratio. They have not asked me to find any of the sides. In fact, sides are all given. But they haven't asked me to go find theta. They haven't asked me, hey, what is this angle? Because this is 90 degrees, obviously. The other two missing angles are these two. Now, can I find that angle? Yes. I'm just one step away from finding the angle. However, keep in mind the question has not asked me yet to find the angle. Now, we know if an angle is missing, that's when we start rewriting the same equation as an inverse problem. The sine inverse of 60 over 61, when you plug that into the calculator, you will automatically get theta, depending on is your calculator set on radian or degrees. By the way, we will be using degrees more in this one, so that's a breather there. This slide is available to you in Schoology. Here's an answer slide worked out for you. And I can move on to something next up. Find the length BC, round to 3 decimal. So it looks like I need to find a side. Clearly, BC is the side. And this is what I'm looking at. X is the unknown. Okay. Again, this is a right triangle, right? We notice a right triangle. So two things should pop up in your mind. I can apply a squared plus b squared equals c squared because it's a right triangle. And second, I can apply all 6 trig ratios to it, the basic ones. Which one is needed depends on the question. In this question, they're asking me for this side, BC, but I only know one side of the 3 sides, right? This is A. I can call this A, I can call this B, and this can be C. B and C are both unknown. So just based off of one, I cannot use Pythagorean theorem, if that makes sense. So I'm like, okay, I can't use this on this question. So let's try trig ratios. They're asking me to find BC. Well, thankfully, theta is given. So this is my reference point. And again, you're standing right here. The first thing you want to do is declare your hypotenuse. That's your opposite. And this is your adjacent. Okay. But I'm like, all right, I got that part. I have to use trig ratios, but there's 6 of them, or 3 of them predominantly. Which one will help me find BC? Sine, cosine, or tangent. That depends on what's given to you and what's being asked. Okay, that depends. So every question is different. Here's a strategy that you can use. Everything basically deals between hypotenuse, opposite, and adjacent, right? Now that I have declared which one's which, they're asking me to find BC, which is adjacent, right? So obviously I have to keep adjacent in picture. I have to use adjacent because that's what I have to find. Then comes in hypotenuse. Let's look at hypotenuse. So you again ask yourself 2 questions. Is hypotenuse given? No. Are they asking me to find hypotenuse? No. And the answer to both that is no, so hypotenuse is not in picture. Which brings me back to this. Since we don't even care about hypotenuse in this question, sine uses hypotenuse, cosine uses hypotenuse, so both of these are out. I can't use them. And that boils down to tangent. Tangent is something that will help me find it. Tangent of theta is TOA, so opposite over adjacent. And let me start replacing. Tangent of theta is 15 degrees, not radians, degrees. Opposite is 10.2 feet over adjacent, which is BC, which is what I'm trying to find. Now look at this as a proportion. A ratio equals another ratio. That's a proportion. 3 of the 4 items here, 1, 2, 3, 4, are known. And that's how proportion should be. There should be only one known, one unknown, which is BC in this case. So what I'm trying to say is that we chose the correct one, tangent. If you would have chosen sine or cosine, you would have ended up with 2 unknowns, and that would have not led you anywhere. Then comes in from here, cross multiply, tangent 15 times BC equals 10.2. I'm trying to find BC, so I'm going to divide both sides by 15 degrees. And when I pick up my calculator and go 10.2 divided by tangent of 15, as long as I plugged in correctly and as long as my mode is in degrees, I will directly get the measure of BC, which let me get from the next slide, 38.067. And this is the length of the side, not the angle. This one's in feet, so obviously this one is also in feet. All right, so what did we do here? We used a trig ratio, specifically tangent, that helped us find the unknown side. Let's look at more examples. Well, actually, next topic. Am I aware of angle of elevation and angle of depression? So angle of elevation is basically the angle, so this is the theta here, that is made directly by your eye contact, basically. So the angle made with the horizontal and the the line of sight towards the object that you're looking at. For example, it's not here. When an object is above or below another object. So if I'm sitting right here and if I'm looking at an airplane or even a bird for that matter, let's say here's a bird, right? So that would be angle of elevation. The angle with the horizontal that the horizontal makes with my line of sight towards that bird. Okay, so this will be angle of elevation. Versus if I am just working on my desk here, and then I see a little squirrel. We see a lot of squirrels, right, in the backyards. So when I'm looking at a squirrel here, then the angle that I'm making with the horizontal, my line of sight, this is my line of sight, and this is the horizontal. That angle is called the angle of depression. Okay, it just matters. It's just a matter of which one's higher, the object or me. So based off of that and our trig ratios, let's see if we can solve this word problem. Example 3. The Pilatus Bahn in Switzerland is the world's steepest cog railway. Its steepest section makes an angle of elevation of 25.6 degrees, not radians, with the horizontal, and rises about 0.9 kilometers. At where? At its steepest section. How long is this section of the railway track? By the way, I did get this picture from the internet of the Pilatus Bahn cog railway. It's in Switzerland. Yeah, it is actually. There were a lot of pictures, pretty sweet pictures, and the cog railway are pretty old, so their technology was pretty interesting. Anyway, so angle of elevation, which means that, let's say the railway this is the steepest section, let's say, and this is the cog railway. So here's the cog railway going up. So the angle of elevation that is made, which again, as I said, elevation is going up, the angle made with the horizontal, so that's theta. By the way, they've given me that theta, 25.6 degrees. Also, they gave me that at its steepest section, this is the angle it makes and rises about 0.9 kilometer. So which means by the time it gets to from point A to point B, the vertical distance covered is 0.9 kilometers. That was a lot. And I have my triangle. Obviously, this is 90 degrees. Let me call it ABC. Question's asking me how long is this section of the railway track? So this is the railway track, keep in mind. So basically, AC is in question, right? AC is what we're trying to find. Okay. And this is the reference angle. So the first thing you want to do is label hypotenuse, adjacent and opposite. Opposite. And this is adjacent. Is Pythagorean theorem of any use here? No, because only one side is given. Two are unknown, so I can't use Pythagorean theorem. Hence, I'm going to use one of the trig functions. Then comes in, which one do I use, sine, cosine, or tangent? Again, based off of how I had told you. Write down all three of these on the side. Hypotenuse, adjacent. That's not too neat. So hypotenuse, adjacent, and opposite. Is hypotenuse in question? Is that what I have to find, or is it given? Yes, that's the one I have to find, so hypotenuse is important. Adjacent, is it given? No. Have they asked me to find it? Nope, 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 nope. Opposite, given? Yes. They haven't asked me to find opposite, but it's given, so it's going to come in handy in finding it. So O and H, which one deals with that? So sine of theta equals opposite over adjacent. Let's start replacing. Theta is given. Opposite is 0.9. Adjacent. Oh, you did not correct me, guys. Well, no, you couldn't say anything. Opposite over hypotenuse. And hypotenuse at AC, which is what I'm trying to find. From here, use your little middle school algebra skills. How do I find AC? I had talked about this in class as well. When we were in middle school, we were taught this trick that since you're trying to find this and it's sitting in the denominator, you can actually swap the positions of these two without messing up the fraction. So this can be written as 0.9 over sine of 25.6. All I did was swapped AC and sine, and it's still a legit proportion. Now all I have to do is 0.9 divided by sine of 25.6 degrees, and that will directly give me AC. I'm hopefully done here somewhere, 2.08. And that will be obviously kilometer. And this one is for about 2.08 kilometers is the steepest section of the railway. Okay. What other type of questions will you be asked, or can you be asked? They are going to be something like this. We've been given a triangle, and they should have marked this. It's a right angle triangle, which means 90 degrees. Oh, I'm given actually two sides. But let's see, what do we have to find? Find the values of the 6 trig functions, so all 6 of them. And when they talk about all 6, I like to make my little handy dandy table with all 6 of them. Sine, and theta is theta, right? Yep, theta is listed as theta. Cosine, tangent, and pause me here and see which 3 go here. Pause me here and see if you can remember. Secant theta, cotangent theta, and what are their simple handy dandy formulas? Over H, A adjacent over hypotenuse, opposite over adjacent, and these 3 are basically flipped, right? They're reciprocals. So we flip them, hypotenuse over opposite and adjacent over opposite. So let's first find the sine, cosine, tangent, and then we can flip-floppy from there. So this is opposite over hypotenuse. Let's label this tangent. This is hypotenuse. This is opposite. No, this is opposite. Okay, and this one's adjacent, right? Why? Because this was theta. This was my reference point. So I'm like, all right, opposite is 70, and hypotenuse, whoops, I don't even know hypotenuse. And that's going to be a problem with each of the 6 trig ratios. So can I find hypotenuse? Well, yes, I can. You know why? Because 2 sides have already been given to me. So I can use my handy dandy Pythagorean theorem. So this is C, because that's the hypotenuse. So you can call that A, call that B. A squared plus b squared equals c squared. 70 squared plus 24 squared equals c squared. This turns out to be, I think, 1596 equals c squared. So when you find c, you have to square root both sides. And c will turn out to be 74. I have a feeling this should be 6. Yeah, but 74, 74 will lead to a 6. So c turns out to be 74. Now I know hypotenuse. I know hypotenuse. I know opposite. I know adjacent. So 74, 24 over 74. 70 over 24. And then we flip-flop them. However, before we do that, make sure this is simplified. Now, simplification doesn't necessarily mean change it to decimal. Just have to simplify. They both go into 2. (35 over 12). Now that I have these three, all I have to do is, if I get their reciprocals, I have found the other 3 trig functions as well. They asked me to write the values of the 6 trig functions. I have written down the values of the 6 trig functions. So this question used Pythagorean theorem, and it also used SOHCAHTOA, knowing all 6 of them and their ratios. Why was I able to apply them? Keep in mind, because the triangle itself was a right triangle. They should have marked it here. I don't like how they didn't mark it. But it is a right triangle. Because if this was not a right triangle, we could not have applied any of this. No Pythagorean, no trig ratios. All right, moving on. Navigation, just something to know. Make sure you go over these notes. This is just 2 slides and it's super easy. Or I'll tell you, in navigation, north is considered to be 0 degrees. North is 0, east is 90, south is 180, and west is 270. Unlike the coordinate plane where we go 0, 90, and all that stuff. So just keep in mind this is the other way around. So for example, if I were to ask you that, hey, could you sketch what direction would south 20 degree east be? So the way you want to read this is that the angle 20 degree is being made with the south going towards east. So which is south? This one's south. So from this, so this is the main arm of the angle or the direction. With this arm, I have to make an angle of 20 degrees going east. But did I go east? I actually went west, I think, right? North, south, west, east. So I did it wrong. So delete this line, delete this line. I need to go east. So east 20 degrees would be this angle. So hence the direction that they're referring to is this. This direction is south 20 degree east. Try these other 3. It's not too bad. It's pretty easy. Just knowing north, south, west, east. Some of you had memorized it as never eat soggy waffles. I just have them memorized. I don't use the abbreviation. KK. KK. Here's another one. Please, please, please practice this. It's just like the last example I did. They're asking me to write all 6 trig ratios, and I cannot write all of them until I know all sides. Keep in mind this is C, and you can call this A, and if you're going to call this A, then B is the one that's missing. So first step will be to find Pythagorean theorem. Use Pythagorean theorem to find B, and once we have B, then please keep your reference angle in perspective. That in perspective to this is the hypotenuse. That's opposite, and that's adjacent. Now that you will know all 3 of them, then you can write those 6 ratios. I highly recommend just try it once. Same thing here. This is an example from Math Excel. You've been given a right triangle, and good thing that they labeled it, that it is a right triangle, and hence you can use Pythagorean. Clearly, C is the one that's missing. So a squared plus b squared equals c squared, which is 10 squared plus... Actually, let me do this one. Okay, here. So let's find C first. 10 squared, 3 squared, a squared, b squared, c squared. This is 100, this is 9. That's 109. So C is basically square root of 109. And you know what? Don't even worry about finding the decimal value of it, because that's going to be long and like unlimited number of decimals. So keep it just the way it is. B, 10, and square root of 109. angle theta in the figure, and everything is in respect to this theta. See that? Which means be very careful in identifying hypotenuse. And then this would be opposite, and this would be adjacent. Now that we have identified them, let's start writing our ratios. Why is it so thick? Sine theta, cosine, tangent, OH, AH, OA. Okay, opposite is 3. Hypotenuse is square root of 109. Adjacent is 10. Hypotenuse is square root of 109. Opposite is 3. Adjacent is 10. Now, watch, be careful. They're not going to take this answer, right? Why? Because of the radicals in the denominator. So this one's good to go, but this one's not. So we will have to rationalize it. That turns out to be 3, 109, square root of 109 over root 109 times root 109 is just 109. Same thing here. 10, don't forget the 10. It's 10 times root 109 over 109, because that times that is 109. Now, you can plug this in the calculator and you can get a long weird decimal answer to it, but there is absolutely no need to do that. Math Excel will take it in the format that I have shown you. Okay, now this is also good and this is also good. But the thing is, those are just 3 of them. Remember, we were trying to find all 6. That's what the question asked me. What are the other 3? Cosecant theta, secant, and cotangent. And with these, I don't have to do as much work. All I have to do is flip-flop them, right? Reciprocal them. Now, don't reciprocal this. Remember, this was the original one. So I can just reciprocal that, because the radical will go in the numerator automatically, and then I don't have to worry about it. Same thing, I'll take this original one that I got before rationalizing it, and then reciprocal that. And 3/10 shouldn't be too bad, 10 over 3. And I have found all 6 trig functions. This was a Math Excel homework example. All right, I think that was helpful. I hope you watched this video, and I'll see you in class next time with the next one. Just to let you know, the next one are going to be non-right triangles, which means we will not be able to apply any of this for those triangles. So we will have more stuff. Until then, see you next time.